Okay, honor chemistry students, this is a video on significant figures, or sometimes we call them significant digits. You should know that they both mean the same thing. And the main idea on here is that when scientists take measurements, we want to try to be accurate and precise, but we also will have uncertainty in measurements. That's because what we measure is everything we accurately know based on the graduations that would be on a ruler or graduated cylinder. And then we imply or we add one guessing digit with our measurement. And that's what would be called a significant digit. So now you can't just write down everything that's on your calculator because your calculator just does pure math. And in science, we're not just looking for the math answer, we're looking for the measurement answer. And remember, measurements have two things. They have, important in science that you know, that measurements will have two things. They have to have the correct number of sig figs. So you got to write down and report the correct number of sig figs, and they have to have a unit behind it whenever we're doing a measurement. So we'll want to know, are you measuring in liters? Are you measuring in milliliters, grams, ounces, kilograms? All of that stuff is important when we're submitting a measurement. So again, significant digits, all the numbers we measure with certainty, plus we get one more guessing digit. So if you take a look at this pin that I have here, and you can see right from here that the pin is somewhere close to, let's see, you would evaluate if I said, what's the length of this pin? You would say, okay, well, at least it's 2.5. It's not quite 2.3. Oh, and then look at, there's more graduations here. And in this graduation, you would have these numbers all right in here that are in between these markings right here. So in other words, you know for sure it's 2.5, and you know it's past 2.6, 2.7, 2.8. So it's somewhere between 2.8 and 2.9, okay? Then what you do with this little marking right here is you, in your mind, subdivide it into 10 more graduations. This is your guess. You know for certain it's past 2.8, and then you're guessing in between. So this reading should be 2.85 centimeters. There you go. That's what you should report. Okay? So it takes a little while to get used to sig figs, but once you do, it's pretty easy. The thing that I also want you to know is that it's dependent upon the type of ruler that you have here. So if we look at this first ruler right here, you can see there aren't as many graduations. And if I asked you, and let's just call this a centimeter ruler. So this is graduations that are in centimeters. We know for sure it's 1 centimeter. We know it's over 2 centimeters. It's not quite 3. So student A could maybe say this measurement is 2.5 centimeters. Do you notice the guess is the 0.5? So let's say that student A said that it was 2.5. Student B comes along and says, no, I think it's 2.6. Is this a valid measurement? And the answer is yes, it is valid. There can be a little bit of estimation in that very last guessing digit. So both of these are valid answers. Now, if you would say something like 2.0, I'm going to mark you wrong. And the reason why I would mark you wrong is because right here, you know, the bar should go right about here. So please be accurate if you are doing this, that you should be looking at where that bar is so that it makes sense. So even if a student said that it was 2.4 centimeters, that would still be valid. Those are all guessing digits, that very last digit. Now let's take and look at the ruler up here. Notice there's more graduations. So now when you read this, you say, okay, here it is, 2.1, 2.2, 0.3, 0.4, 0.5, 2.5 for sure. And then it's not quite to 2.6. So let's say student A says it's 2.55 centimeters. And student B comes around and reads it, and they say it's 2.56 centimeters. Both answers are valid, and this is the guessing digit. Do you notice how the guessing digit goes out one placeholder? That's because there's more graduations here. So in these right here, I'm going to put it in green, you have total confidence because you see the markings. The last digit is the guessing digit. And depending upon what you're given for a number, so like here you're given 2.55, or if you're given 2.5, there's like hidden meaning with the number of numbers you're given here. This tells you there is less precision in the instrument than there is in the ruler above. Okay, so that was also that second meaning you heard in Paul Anderson's video of that word precision. It can have two meanings. All right, so here's what I would recommend doing is I'd recommend pausing and writing out this chart because this is something you're going to want to have in your notes. So pause your video now and write out the chart. Okay, you're back. So hopefully you have this written down. These are the rules for significant digits and kind of like how to figure out what to count and why you count them and all that kind of thing. So the first thing we're going to talk about is non-zero numbers. So here you've got a number that has no zeros. You count all of them. Every digit is significant in this case. So since you have 4 digits here, there's 4 significant figures. Leading zeros are never significant. They're actually what we call placeholders. And since they are here, even though there's a decimal place, they are leading in front of non-zero numbers. So in this case, these are never counted as significant digits. They're just placeholders. And the number of sig figs is 2. So you should fill that out on your chart. Then there's something that's called captive zeros. And captive zeros are when there's zeros kind of embedded between numbers that are not zero. And when you have captive zeros, you're counting all of them. So this would be 9. 9 digits here, 9 significant figures. Now trailing zeros would be zeros after the decimal point. And in a trailing zero, if you don't have a decimal point, there's only one, which would be this right here. If there is a decimal point, you count all of the zeros. So in this case, there's 4. And then finally, we can do scientific notation. So with scientific notation, you count everything that is in front of the times 10. So here I've got 3.7 times 10 to the negative 2. 3 and the 7 would be counting as significant figures, so there's 2. And here I've got 4.0307 times 10 to the 4th, and there's 5 digits that are here in front of the times 10 or times 4, so that's why I'm counting 5 digits as the number of sig figs. So hopefully you have that in your notes. If you haven't gotten everything down, because I know I talk fast at times, you should pause and get this all in. It's a good thing to have in your notes. You do need to know these rules. Okay, well, what about when we have instruments? And I just want to show you some common instruments that we have that you should be able to know how to read. These would be instruments we have in our laboratory. So the first thing we're going to look at is the 100 mil graduated cylinder. And if I asked you, if it gave you a picture like this and said, what is the volume? The first thing you notice is that the graduations are going up by ones. This is 50, and clearly that's 60, and you have 10 graduations in between. So you know with confidence this is 51, and that is 52. You want to read the bottom of the meniscus, and again, it's harder a little bit in a picture than it is in the laboratory. So we're kind of reading right into this area, and we're saying 0.7 is the guessing digit. Would Jack or Jill be wrong if they said 52.6 milliliters And the answer is no, because that's definitely within the range of what one person would read compared to the next as far as looking at these digits. The 25 mil graduated cylinder is a little strange because this is exactly the same kind we have in our lab. This would be the 21 milliliter marking, and this would be the 23, and then there is a marking here that would represent 22. So they go up by 0.2s. So 21.2, 21.4, 21.6. So the graduated cylinder, when you have a 25, you're going to end up with this being your guessing digit, and it can only go up by 0.2s. And I kind of cut you a break on that. We don't use the 25 mil graduated cylinder very often in our classroom, in our laboratories. Finally, the 10 mil graduated cylinder, this is an example of the one that we have in our class. And actually, they go up by 7s. So, or I'm sorry, by 1s. So there should be a 7 here. I don't know why there isn't in this picture. And with these, you can guess as the guessing digit into the hundredths place. So that's just to give you guys some idea on how we're going to look at these instruments. And the first time we pull them out, since we had to do this kind of on a video rather than doing it as per lab, we will talk about this as well. Finally, the digital balance. So if you're given a digital balance and you got to figure out the number of sig figs, this one's easy because you get to read what's on the scale. Most of our digital balances we're going to want to read in the hundredths place, okay? And that is also considered your guessing digit right here. So this would be your guessing digit as well. So digital balances will be really easy for us to see. One thing you should know about our digital balance, there's usually a range button. If you see the balance and it's only showing to the tenths place, you're going to want to hit the button on range in order to see to the hundredths place. All right. More on significant digits. If you have a counting number, they are always significant. So say somebody counted 250 cars in the parking lot. Yes, there's no decimal point here. Yes, this is a trailing zero, but since it was counted, it wasn't something that was measured, it has 3 significant figures. If you are talking about a constant, like the speed of light, or something called Planck's constant, which we'll talk about in the next chapter, or pi, they have an infinite number of sig figs, and they are never considered in the sig fig calculation. So that was my lesson just on identifying. The next lesson is going to have you practicing identifying the number of significant figures, and then we will also talk about mathematical operations. So you should go on to the next video.